Hey guys, welcome back. In this lecture, we discuss about a continuous beam. This lecture is for practice of continuous beam with different loading and how to read a post-processing data after analysis. So let's open a Stat Pro. Go to new project, plane, next, yes, finish, front view, create one node at 0. Look at this. There is one continuous beam. The first beam length is 2.5 meter, then 4 meter, and then 4.5 meter. We created a one node at 0, 0, 0. Just take node cursor, select that node, copy it and paste it in x direction 2.5 meter. Okay, select the next node, copy and paste in x direction 4 meter. Okay, select the node, copy it and paste it in x direction 4.5 meter. Take add beam, join all the nodes, go to general, property, define rectangle, yd is 0.3 and z is 0.2 meter, add and close, go to assign to view, assign and yes, support, create, look at the supports, all the supports are pin support, create pin support, add, select that support, go to assign to view, assign and yes. Load and definition, load case detail, add, title should be load, add and close, select that load case, go to add, member load, first one is a point load or concentrated load of -10, so go to concentrated force of -10, add this one, second is a concentrated movement of 4 kilonewton meter which is in clockwise direction, so we have to provide in minus concentrated movement -4 and zz direction. Okay, add, the third load is trapezoidal load from 13 to 18 kilonewton per meter. Just go to trapezoidal, provide W1 as -13 and W2 as -18. Value of D1 is 1 meter and the value of D2 is 3.5 meter. That is, this distance is 2.5. Okay, D1 is 1 and D2 is 3.5. Add and close, assign all the loads one by one. Moment is applied but it is not visible. Look at this. Okay, go to analyze, print, add, close, analyze and analysis, save. Go to post processing mode and done. Okay, look at the displacement diagram, just hold control and scroll your mouse in front side, the middle button of your mouse. Go to results, view value, beam results and maximum displacement, annotate, close. Now you can see a maximum displacement value for each beam in the displacement diagram. Okay, just close this one, Go to the results, view value, beam result, close this, and on the bending values, annotate. Okay, must the bending diagram must be on. So just on it from MZ, hold your control button and scroll your mouse. Okay, it's your bending moment values for all the end of the beam, mid of the beam, and maximum value. Okay, the value is overlapping, so just take a beam cursor, select that particular beam, go to view selected object only. You can see the value clearly. Okay, display whole structure, close this diagram, and on Fy as shear force. Go to results, view value, beam results, and check the shear and maximum and mid. Annotate, close. These are the shear force values. Okay, now go to node displacement. Look at this table. In this table, you will find out the displacement values at a different location of a different beam. Beam number 1 at a 0 meter distance means start point of the beam. There is no deflection. The value of deflection is 0.000. At the 0.625 meter length, which means somehow the 1/4 length, the displacement is minus 0.316 mm. At the center of that beam, displacement is 0.473 mm. At this location, the displacement is 0.351 mm. At the end of that beam, the displacement is 0 because there is one support. Like that, you can see the displacement for beam number 2 and 3. Okay. For the maximum relative displacement, just go to maximum relative. You will find out a maximum relative displacement for all the beams at a location and values. For first beam, the beam length is 2.5 meter. At the location of 1.667 meter, the maximum displacement is minus 0.473 mm. Okay, and the distance is from the start point of the beam. Okay, which is the start point of the beam. Just take beam cursor and hold your mouse cursor at your beam. It will appear in three colors: green, red, and blue. The green color shows the start point of the beam, and the blue color shows the end point of the beam. So the value of distance in meter is from start point of the beam. Like that, you can see for the second beam and third beam. Press Shift plus B for beam numbers. Okay, go to reaction. You can find out the reactions in the screen and table also. There is one table for support reactions. Go to summary, envelope, and all. You will find out in Fy the vertical reaction, horizontal reactions in Fx and Fz, and the moments in Mx, My, and Mz. If we apply a fixed support, there will be movement also. Okay, for node number, just press Shift plus N. Alright, go to beam. It's a bending moment diagram, and the values of bending moment are present in this table. Look at this. There is the beam number 1 for load case 1. Distance is 0 meter, which means at the start point of that beam, The value of shear force as Fy is 6.396 kilonewton. Just on the diagram of shear force, the blue one is shear force diagram and the red one is bending moment diagram. The value of bending moment is 0 because it's a pin support. Okay, at the distance of 0.625 meter, somehow 1/4 of the beam, the value of shear force is 6.396 kilonewton and the value of bending moment is minus 3.998 kilonewton meter. At the center of the beam and length is 1.25 meter, the value of shear force is 6.396 kilonewton and the value of bending moment is minus 7.995 kilonewton meter. Okay, like that you can see all the values for bending moment and shear force. Just go to the maximum axial force, maximum bending moment and maximum shear force to view maximum values, the maximum positive value and maximum negative value. Maximum positive bending moment is 0 and maximum negative bending moment is minus 7.995 kilonewton meter. Okay, in second beam, maximum positive bending moment is 16.384 kilonewton meter, which is at the location of 4 meter from the start point of that beam, from the green one. Okay, and the negative maximum bending moment is minus 3.490 kilonewton meter, which is at the start point of that beam. At the third one, in the third beam, there is maximum positive bending moment at a start point of that beam and a maximum negative bending moment at somehow location 2.625 meter from its start point. In this location, the maximum negative bending moment is minus 23.92 kilonewton meter. Alright, maximum shear force for first beam, maximum positive shear force is at a distance of 0.00, which means the start point of the beam, is 6.396 kilonewton. Maximum negative shear force at a distance of 1.458 meter, the value is minus 3.604 kilonewton. Like that you can see the maximum shear force values for beam number 2 and beam number 3. Okay, just practice all the previous videos and write it down in your notebook, the values of maximum bending moment and maximum shear force, and draw all the bending moment and shear force diagrams for all the simply supported beams with uniformly distributed load, point load, uniformly varying load, trapezoidal load, and all the continuous beams with point load, uniformly distributed load, uniformly varying load, and trapezoidal load. And then all the continuous beam with mixed loading, which means in a one continuous beam there are different loading. So practice all the uh, lectures, all the problems, and observe bending moment values, shear force values, and displacement values. Okay, just go to the graph. Look at this. Just click on first beam. There is a graph of bending moment as mz. There is a graph of shear force as Fy, and Fx is the axial force. Since there is a no axial force in this beam, so there is no graph. Click on the second beam. It will show a graph for beam number 2. Click on the third beam. It will show graph for the third beam. Go to animation, section displacement. Okay. Go to the beam and stresses. It will show all the stresses in this table: maximum stress and profile stress point. Okay. Thanks for watching this.